Our next method for multiplying decimals is a visual method. This is using decimal grids, or really area models, and the distributive property. And technically, we've already done this when we did mixed number multiplication. So if we look at this example, we have two numbers that we're multiplying together. I have 4 and 9/10 and 3 and 5/10. And so one way that we could think of this is to change them to fractions, 4 and 9/10 times 3 and 5/10. And what we would have done before when we did this area model with fractions is we draw our rectangle, and it doesn't really matter which side is which, just make the bigger number the longer side, right? So in this case, my longer side would be 4 and 9/10. And what we did is we split that up, right? We split up the 4 from the 9/10, and then the other side would be the 3 and the 5/10. And then we just subdivided our rectangle, right? So we had our 4 separate sections, right? And so when we did this with mixed numbers, this is what we did, right? We just split up the whole number part from the fraction part in each number. And this made it a little bit easier to do the multiplication, because rather than having to do, 4 and 9/10 times 3 and 5/10 in our head, we could just do the 4 separate multiplications, which are a little easier. So 4 times 3, that's 12. Those are things that you can do relatively simply in your head, right? So we know if we find the area of all 4 rectangles and then add that up, then that gives us the area of the whole rectangle, which is what we're trying to find, right? Length times width, the area of that whole rectangle would give me the multiplication, the answer to the multiplication that I'm trying to do. So this is what we're going to do essentially with decimal multiplication. When we want to do a visual, we can do the same area model. The difference is we're just not going to change them to fractions. So instead of changing it to fractions, 4 and 9/10, 3 and 5/10, we'll just leave it as a decimal. So instead of writing that as a fraction 5/10, let's just write it as a decimal 5/10. So instead of 9/10 as a fraction, let's just do 9/10 as a decimal. And then we're going to go through doing this multiplication using the distributive property. So from here, if I wanted to show my work here, what I would do is I would actually split up my numbers the same way I split them up on the figure. So 4 and 9/10 is really 4 plus 9/10. And then I'm multiplying that by 3 and 5/10 is really 3 plus 5/10. And then I'm going to distribute, right? So if I were to distribute this, distributive property on something like this uses something called the FOIL method, which you may or may not have learned. It just means first, outer, inner, last, or in other words, you're multiplying every term in each parentheses times every term in the other parentheses. So I could start with my first two terms, 4 times 3, which is going to give me this box, right? So 4 times 3, which is going to give me 12. And then I'm going to move on to my outer term. So 4 times 5/10. And so that's relatively simple to do in my head. And that's really talking about this box here. So 4 times 5/10 is going to be, so 4 times 5 would be 20, but then I would move the decimal over one space, right? So I end up getting 2, right? Because if I had 20, but then move the decimal for that one digit behind the decimal, and I get 2. You could also think of that as 0.5 is really a half, so half of 4 is 2. And then, so I did first outer, I need to do the inner terms. So the inner terms here would be the area of this rectangle. The length there is 3 and the width is 9/10. So 3 times 9 is 27, but of course I need to move the decimal over one space. So this is going to end up being 2 and 7/10. And then finally my last terms, 9/10 times 5/10, which is going to give me this little box here. 9 times 5 is 45, but I'm going to have to move the decimal this time 2 spaces. So this is going to be 45 hundredths. And then I'm just going to go through and add all this up. So if I add the area of all 4 rectangles, that'll give me the area of the large rectangle, which is what I'm trying to find. So let's see, I could easily do 2 plus 2 and 7/10 would be 4 and 7/10. And then bring down the rest. And then let's see, 12 plus 4, that would be 16. So this is going to be 16 and 7/10 plus 45 hundredths. And then finally, I'm going to, however you like to best do this. Remember, when we're adding, though, we have to line up the decimals. So this is going to be 7 plus 4 is 11. Do some regrouping, and you don't have to use the standard algorithm. You can use whatever method you prefer for adding your decimals together. And so I get here 17 and 15 hundredths. So this was using an area model, but technically what we typically do with decimals is we use decimal grids. So I'm going to show you the way that you would do this most often. Most often you wouldn't freehand this, you would actually use a grid, right? But it's the same idea. So we know that in decimal grids, every small square is 100th, right? And so if we wanted a flat, that would be a 10 by 10, right? So if I want to do this same figure, but on the grid, right? What I'm going to do is I'm going to go ahead and split up my 3 from my 5/10, right? I'm going to split that up. But we know that if I want it to be 3 units long, that's 3 flats, right? Because a flat is a whole. So I'm going to just count here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 3, right? So here is the 3 part of my box. And then I need 5/10, right? So I'm just drawing the same thing as what I did earlier with my area model. I'm just making it to scale, right? So 5/10 would be 5 grids long. 1, 2, 3, 4, 5. So that's like the top of my box here, and I've already started subdividing this into sections. And then I'm going to need the 4 and the 9/10 along the left-hand side. So I'm going to count again. Every 10 is 1 whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 4. So this is going to be the side of my rectangle. That's the part that's going to be 4. And then 9/10 is going to be 9 grids long. Hopefully I've got enough space here. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And let me just extend all these so that we can see our box. So I've just tried to make those nice and dark so we can actually see those on this grid. And you can see that what we have here so far is the same thing as the original setup. It's just to scale, right? It's the same figure that we drew earlier. This is just how we would do it on a grid in order to make that figure to scale. And then what you can do is you could go in and label, right? So like this was 4 times 3 and this was 4 times 5/10. But what we would typically do actually is we would go ahead and put in our decimal grids, our flats and our rods and our units, right? Or our small cubes. So what I would do is I would try first to fit as many flats as I can. And if flats don't fit, then I go to rods. And if rods don't fit, then I go to my small cubes. So every flat is a 10 by 10, right? So I can see in this case, I can actually fit, here's a flat. And I left those marks there, so that makes it a little bit easier. Every 10 is already kind of counted out for me. And I'm going to fit as many flats as I can in this first box. When I'm done putting my flats in, what I should be able to do is actually just count how many flats fit. And in this case, that's going to be 12. So each flat is one hole, and I have 12 holes here. So that's where this answer comes from. So this is actually another way, an easier way to do the multiplication is just to count, right? Count my flats, rods, and units. So the next thing we did was we moved on to the outer terms, which was this box, right? And on this box, I can't fit any flats. So then I would fit my rods. And so my rods are 10 units long, right? And so I can see I can fit 1, 2, 3, 4, 5. So 5 rods there. But then I can fit another 1, 2, 3, 4, 5 rods there. And another 5 here. And then another 5 down the bottom. So in this second box, got lots of rods here. So I'm trying to make these lines darker so you can see. So you can see the separation here. So every rod is 10 units long, and you can see I've got 5, 10, 15, 20 rods, right? So I have 20 of those, but that's 20 tenths, right? 20 tenths, which really means you move the decimal one space to the left, and that's how we get 2. So then let's move on to the next box. So here, could I fit any of my rods? So I can't fit any flats. It's close. It looks like it if you're not careful, right? But that's not a flat because it's not a 10 by 10. But I can fit some rods. So I can fit, there's 1, 2, 3 rods on the first row, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then at the bottom now, 25, 26, 27. So I have 27 rods, or 27 tenths, and dividing by 10 means I move the decimal one space. So that's where we can come up with the 2 7/10. And then finally, let's do our last box. So for our last box, we can't fit any flats and we can't fit any rods, so we can only fit our units. But we have 9 going this way, and then we have 5 going this way. So 9 times 5 is 45. 45 little small cubes, or 45 hundredths. 45 hundredths as a decimal is 0.45. So that's where we're coming up with the 45 hundredths right here. So this is the same thing. This is just how you would show it on a decimal grid. So you just do it to scale, and then you draw in your flats, rods, and units, or small cubes. So if we look at this one, the figure's already drawn for us. They just want us to label it. So we can see that they've got three flats going across. So that's going to be 3. And then we've got 1, 2, 3, 4, 5, 6 rods here. So that would be 6 tenths. Then there's 2 flats going across, or I'm sorry, going down. So that's each flat as a whole. So that's 2. And then this is 1, 2, 3, 4, 5. So that's 5 tenths. So we can see that this is actually the multiplication problem, 3 6 tenths times 2 5 tenths. And then they've essentially done the multiplication for us, right? So if we were going to show this with the distributive property, we would say this is really 3 plus 6 tenths times 2 plus 5 tenths. And then we would do our multiplication. 3 times 2 is the green box, right? Is going to give us 6. And then the outer terms, 3 times 5/10. So that would be the dark blue box. And that's 1 5/10. And then if we do the inner terms, 6/10 times 2, that gives us this like teal color box or light blue. So that's 1 2/10. And then finally, if we multiply our last term, 6/10 times 5/10 is 30, but then move the decimal. So we get 30 hundredths or 3/10, same thing. And then we just add all these up. So if we add this, we're getting, let's see, 1 5/10 plus 1 2/10 would be 2 7/10. And you can add these in whatever order. This is just the order that makes sense to me. I don't technically need the 0 on the 30 hundredths. I could just say that's the same thing as 3/10. So 2 7/10 plus the 3/10 would actually just give me 3. And so my answer here is 9.